Right, so now we move on to our last but not the least either. It's using the inverse to solve a matrix equation. So sometimes we'll have the inverse and then we'll use it to find a system of equations, right? It's also very simple. It's basic mathematics. So ax is equal to b. Every equation that we'll ever solve, like simultaneous equations, are in this form, right? We can express it in this form. So A is a matrix called the coefficient matrix. X is the variables in the equation, and B is the equation into the right hand side of the equation. Fine, if you don't understand, I'll explain it. It's very simple. So let's take a system of equations like this. 5x, right, from here, I'm copying from here. 5x minus 3y is equal to 28. And then minus 2x plus 4y is equal to 14. 1, 2. We can solve these equations with matrix. So what's A? What I can write, what we call the coefficient matrix. It is the coefficient of every single variable turned into a matrix. So we call it the coefficient matrix. So in this example, the coefficient matrix will be 5, 3, minus 2, 4. This is the coefficient matrix. Then x is made up of the variables. So just x and y are the variables. So x and y. And then b is called the right hand side, right? It's a matrix made of the right hand side. So just 28 and then 14. Perfect. So what we just did, we converted the system of equations here, this system of equation, into this form, the form ax is equal to b, which is a form in which we can use inverse to solve. So let me give you the logic behind it. This is the logic behind it. Ax is equal to b. It's obvious that it's x we are looking for because these are the variables. You can find this x, then we'll find the values of both x and y in here, right? So this is what we do. We pre-multiply it here. Pre-multiply both sides by a. So if I multiply here by a inverse, right? Multiply both sides by a inverse, right? So like basic algebra, that's what we do. And we do it in algebra sometimes. Multiply both sides by something to make something simpler. And then we know this. We've seen this somewhere. Whenever we multiply a matrix by its inverse, it's a property. It gives us I. So this reduces to Ix is equal to A inverse B. But we know that I is the identity element or the identity matrix. It means whenever I multiply it by anything, that thing doesn't change. So our answer remains X is equal to A inverse B. Right? Our answer remains A inverse B. Our answer remains A inverse B. So this is what we'll be using. I think they should be in red ink. Oh, it's wrong with you. Right. That is what we'll be using. So that's what we just need to know, to memorize or to keep in mind, to be able to solve A is equal to A inverse B. X is equal to X inverse B. A inverse B. That means that in this equation, in this system of equations, if we want to find x, which is x and y, if matrix x, if we want to find this, then x is equal to A inverse. This is A, right? Because this was A. A inverse times B. So I can just find A inverse, right? Then I'll find, I have B already. B is from here. If I can find these two, then I can find x. So let's try it. What's A inverse? A inverse being my 1 over determinant of A multiplying its cofactor matrix. looking at the matrix A, its cofactor matrix will be first return this, right? So we have 4 and then 5, right? And then we'll negate this, -3 and then 2. Perfect. Let's now substitute the determinant. What's the formula for determinant? So A inverse is equal to 1 over, determinant is given by product of the forward diagonal minus that of the lead backward diagonal. The forward diagonal product is 20 minus the backward diagonal, the product is -6. Then 4, 5 minus 3. Perfect. We have 1 over 26 multiplying 4 minus 3, 2, 5. That's simple, right? So this is our inverse. We could simplify it to 1 over 13, maybe 1 will be 2. 2 over 13 minus 3 over 26. 1 over 13 and then 5 over 26. Right? That's easy. That's the inverse of A. Now all I need to do is to multiply the inverse of A, which I have here, by B, which I have here. Right? Perfect. It's so easy, right? It's very easy. So let's multiply. We have 2 over 3 times 28. That's just 56 over 13 plus this times this. We have 30, 40, 42, right? Over 26. That will be minus. It will be minus. Let me change it. It will be minus. Oh, please. Whoa. Oh shit, we lost everything. We lost everything, but we'll still do it again. It's easy because we wrote it, so we'll just do it again, all over again. But now let's do it all over again. Please don't tell me this is happening once more. Right? Yes, good. So we'll have our A. So alright, we can continue from here. We have A, X, and then B. Right? We found the inverse. The inverse was given by 4. That wasn't our inverse. Right, let's start afresh. Right, A inverse will be given by 1 over 20, right, plus 6. Right, multiplying 4, 5, 3, 2. If you expand, that's not the inverse we got. That's 20. 20 minus 6. Right. Our determinant is wrong. If you do the determinant here, will be 20 minus this times this is 6. So minus 6, that's 1 over 14. right? So that's how it is. Right, this is it. It's perfect. Right, this is it. It's perfect. So we can, that's our inverse, right? So this is our inverse. We can decide to leave it this way, right, and just multiply by b. So I'll choose to leave it this way because of the fraction in there. If you multiply, it will be a little complex for us. So that's our A inverse. This is our A inverse. We have our B from here. We got B's elements from here. So let's find A inverse B so that we get our values for x, right? So now we have 1 over 14, 4, 3, 2, 5. Right? Then multiply by 28, 14. Let's find the product here. You can decide to keep 1 over 14 outside. Oh, yeah. And multiply this one. So let's multiply. We have 4 times this. That's 28. 4 times 28. Wait. That can't be. Or can it be? Because if we multiply, right? So we have 4 times 28 plus 3 times 14. That's 4 here times 28 plus 3 times 14. We have 154. Then 4, then 2, right, times 28 plus 5 times 14. We have 126. If you multiply, if you simplify, then we have 154 divided by 14. That's 11. And then we have 126 divided by 14. That's 9. Perfect. So our value for x is 11, 9. And then we know that x is equal to xy up there. So it means x, therefore x is equal to 11 and then y is equal to 9. This is perfect. This is perfect. Right, that is perfect. Right, so we move on to solving. Right, so there are other examples here you can try. The last subtopic, that is using the Cramer's rule to solve a system of simultaneous equations. That is up here, using the determinant to solve simultaneous equations. So apart from using the inverse to solve the simultaneous equations, we could also use a very different method called the Cramer's rule, which makes use of the determinant alone, no inverse, right?